Welcome to TomoMask, the Tomogram masking tool. In this brief video, I would like to introduce you to some of the features of the program. After launching the program, the startup screen allows you to open an existing project or to import some new images. New images can be imported directly from a folder, or they can be selected from a DICOM directory. Here, for example, we are loading some TIFF images of a locust from a folder. When these image slices are reconstructed into a 3D view, we find the image of the locust is obscured by the specimen tube. To improve the view, we need to mask the tube by setting the pixels of the tube to the background color, that is black. If we look at the first and the last image in the series, we can see that the tube is angled slightly to the axis. Therefore, we cannot use a fixed mask. The mask must adapt to the tube location. I will demonstrate two ways in which this can be done using TomoMask. But firstly, I would like to quickly mention navigation and how functions are applied. The navigation controls allow us to move through the dataset. We can use the slider, type in a slice number directly, move to the end or to the start of the dataset, or use the increment or decrement buttons to jump a preset number of slices, for example 1, 5 or 10. This last feature is useful when creating interpolated masks. We can also move through the dataset by pressing the number keys on the keyboard. For example, if I press and hold the number 3 key, we scan through the slices in steps of 3. The functions available to TomoMask are listed in the function library. For example, there are tools for creating automatically interpolated painted masks, luminance masks for thresholding, dilation and erosion functions, and filters. We can crop the images and reduce the size of the dataset by removing slices and pixels. There are also tools for measuring distances, areas and volumes, and pixel statistics. Functions are applied by moving them from the function library here on the left across to the active function list on the right. This is done by selecting the function of interest and by clicking this button. The control screen for the function immediately appears, in this case the luminance mask. We shall use the luminance mask to remove the tube. The luminance mask is a comprehensive tool for creating masks by thresholding the source images. The function allows pre-filters to be applied, masks to be dilated, eroded, opened and closed, and areas to be filled. The luminance thresholding can be applied to all pixels or to only connected regions. Pixels which have a luminance between the lower and the upper thresholds are masked with the current mask grey level, that is the default of black. So to mask the tube, we will firstly apply an averaging pre-filter to reduce some of the luminance noise. We will take a sample of the mean grey level of the tube, and then finally adjust the lower and upper thresholds to cover the tube with mask. Now we can see that we also have masked some of the locust. To remove that, we will choose to mask selected regions only. We can also see that we have a little bit of the locust wing connected to the tube, and in this case we can reduce that by opening the mask by 1 pixel. Okay. Click OK, and we are calculating now the connected regions, which are shown in different colors. Select the region of interest, which is the tube, press OK or enter, and we are now calculating the connected region mask. When it is finished, the luminance mask control window will close and we will display the images with the applied mask. So if we jump to the end of the data set, for example, and then just scroll backwards in steps of 3, we can see that the mask has been applied to remove the tube. To save the images with the mask applied, we choose File, Process Images, select the output image format, either same as source, PNG or TIFF. We shall choose same as source. Select a path to the output folder. We shall put them on the desktop. New folder, example 1. And click OK. And the program goes through the images, applying the masks, and saves them to the output folder. An alternative method of masking the tube is to use the paint mask. Firstly, let us delete the luminance mask and add a paint mask. The basic principle of the paint mask is that masks are drawn on key slices. Between the key slices, the masks are automatically calculated by interpolation. So, for example, I could define this slice as a key slice and paint a random shape. I shall fill that by pressing F on the keyboard. I shall increment 10 slices, define a new key, and just modify the shape somewhat. I'll fill that area and delete a part of the mask here, for example. Now if I step back in steps of 1, the green shows the mask which is interpolated until eventually we arrive at the first key mask. Okay, to remove the tube, I will use the shape functions at the start and end of the dataset and allow the program to interpolate between. So firstly, let's start with a new paint mask. Move to the beginning of the dataset. Define a new key, and we want an external circle defined by 3 points. So I just click inside slightly the tube at 3 points, and we've defined our mask. I now move to the end of the dataset, define a new key, clear this existing mask, and draw a new mask. Again, 3 points inside the tube, like so. And now if I step backwards, say in steps of 10, we can see that the tube has been covered by the green mask. Click OK to apply the mask, and the tube has gone.